Good morning, this is P. Venkata Mahesh, Assistant Professor in Mechanical Engineering Department, Institute of Aeronautical. We are discussing some topics on object-oriented programming, and in today's discussion, we'll see something about the multi-threading that we can do in the Java program. Now, what is multi-threading? Multi-threading is an essential concept in programming that allows multiple threads independent paths of execution. So, a thread means it is an independent path of execution. If I am using more than one threads at a time, then it is called multiple threading to run concurrently within a single program. So it is not like that each different programs are using different threads. Rather, in the same program where it is being run on parallelly on different threads. So that is called multi-threading. So it is particularly beneficial for improving performance and resources utilization, especially in scenarios where tasks can be executed in parallel. Say suppose if I have two independent tasks to be performed, then I don't have to wait for one task to complete to start the next task. So in such kind of scenarios, what I can do is I can make the two different tasks of the same program run parallelly on two different threads, so that the performance will improve, and whatever resources that I have in CPU, say suppose I have the CPU of say suppose 16 threads, okay, and if I am using only single thread, then it is the resources are getting wasted. So instead of doing that, what I can do is I can use multiple threads for executing the different parts of the same program. Then it is called multi-threading. So what we'll discuss today is about multi-threading. First we'll see what is the difference between the multitasking and multi-threading. Then we'll see the real world examples of multi-threading. And then we'll go for what are the advantages and disadvantages of using multi-threading. Now multitasking refers to the execution of multiple tasks or processes simultaneously. Say suppose I am using say suppose in the present situation where I am using the PowerPoint, and I am using the video recording equipment. The screen recording thing, and there is a browser that is open, and other things are also open. So all these different tasks, they are being performed by different processes. So our processors are threads. So this is called multitasking. On the other hand, what is multi-threading? So it is a subset of multitasking where single process is divided into smaller threads that execute concurrently. So what we are doing here is we are breaking the single task. Rather than we are using more than one task, we are breaking a single task to be run on many threads. That is called multi-threading. So here in multitasking, each task may run independently and may not necessarily share same memory space. So in multitasking, what is happening is each task is running independently. So and there is no chance of using the same memory space, because the memory used by one task is different, and the memory used by the another task is generally completely different. On the other hand, the threads share same memory and resources, making them more efficient than multitasking. So the multi-threading, on the other hand, it shares memory, because when different tasks can be performed using the same variables. So that is the sharing of memory and resource. Now the example of multitasking is like this: listening a music while browsing the web. So we are using two things at the same time. We are playing the music player as well as the browser. We are working on browser. On the running multiple applications on computers such as browser, text editor, multiplayer, etc. So this is the one example of multitasking. On the other hand, what is multi-threading? So multi-threading is downloading a file in a browser while continuing to browse other web pages. So what we are doing is when the same browser we are using, but we are doing two different things. Here we are using browser, we are using music player, two different tasks completely. But here the same browser is doing two things. One is downloading the file, the other one is the browsing, general browsing also. So this is a multi-threading example. Now coming to the real world examples of multi-threading. So the word process. So typing, saving, formatting and spelling checking happen simultaneously using different threads. As we type, you can see that spell checking is also happening, and sometimes auto formatting is also happening in your word process, and sometimes after a repeated, frequent intervals of times, the auto saving is also happening. So even though you are not saving, in background after a few, after some time, you can say periodically, the saving is happening automatically. So this is one very, day to day, in your day to day life, we are going to see this very often because everyone is going to use the word process. So this ensures smooth performance and responsiveness. So if my computer is having only one thread, so what happens is while I type, the spell check cannot happen, and the formatting also cannot happen. So it has to wait. When I stop typing, then it can go for auto formatting. After auto formatting, then it go for spell checking, and then it can go for the saving. So the operation is when the same word is doing in the same word, we are doing 4 different things simultaneously. Then it is called the multi-threading. So if I have the ability to use, say suppose if my process are, say as I said, I have many threads in my processor. Okay, if I am having many threads in my processor, and if I am using one thread only for doing this operation sequentially, then it is a waste of resources. All these processes are sitting idle. So instead of that, what I can do, I can have these 4 tasks run on 4 different threads, so that better usage of resources can happen. Next, web services. So the HTTP servers uses thread pools to handle multiple client requests concurrently. So there will be, all the servers, all these days, as the internet browsing is is becoming more and more predominant, and all the internet banking and all those things are becoming more predominant. So what happens is the servers, they have to handle so many clients at a time. So when these servers are handling so many clients, they cannot wait for one client. The one person cannot wait. So the modern day servers, they have many threads in their process. So the maybe 64, or the small computer I used, it was having 64 cores. So when in the modern days, where the big banking sectors, where the clients will be generally more. So there we can see thousands of cores also, because it is a huge server that they are going to use. So the IDEs, the integrated development environment, like the IntelliJ, IDEA, Eclipse, all those things, they while we write the code, error there, it will show some errors also, and it will show some suggestions also. Say suppose if I try to write a print, as soon as I write a print, it will give a P. It give a prompt of showing so many options starting with P, and sometimes it will also give some simple errors also it will show. So this kind of environments, they will use the multi-threading so that the performance will be better. Then the gaming. So the modern games, different objects and characters often run as separate threads. So you can see all these games that children are playing, like different people are shooting, and the background is changing, and so many things are happening simultaneously. And if you observe that on smaller process, the gaming experience will not be so smooth, because the number of cores are limited, so number of tasks, the multiple threading ability will be less. But when you have more when process on your computer, the gaming experience will be better, because you are going to use more threads for doing these operations, and the it will be very smooth. So for example, game might use one thread for rendering graphics, another thread for handling input, and another thread for in other things also. So uh, so many things are there in gaming. So like the players have to give input, what the what they have to do, and similarly background graphics also, so many effects will be there. So this kind of gaming needs multi-threading, otherwise it will not be a good experience. The next one is advantages of multi-threading. So the parallelism, I am able to do many concurrent tasks or parallel tasks at a time. Or they say, or I can, what I can say is I'm able to break this big task into small tasks, and able to do in multi-threading and improve performance. As I discussed already in the examples that I have seen, it improves the performance of the the Word or the gaming software, or the browsers, or all these things, so that when the utilization of this CPU cores, as I said, I may have many cores, and if I'm keeping all these cores ideal and using one core at a time serially, then all these resources are going waste. So what we can do is, what we are doing with multi-threading is, we are utilizing the CPU cores more efficiently, and in that way, what we are doing, we are improving the overall application performance. So that is the one advantage. The next advantage is responsiveness. Responsiveness means, say suppose I give one input, and the computer has to take, and simultaneously if the background change also has to happen in the gaming experience, if you want to say, I have only one core in my process, in my processor. So what happens is, I will give input, and next input I will not be able to give, because the other tasks have to be performed before I give the next input. So that the responsiveness will become very it will become slow. So if I use this multi-threading, the responsiveness it becomes more it will become more better, actually, you can say. The application remains responsive even long running tasks. So what happens is, I am continuously giving input. Similarly, the backgrounds are changing, and similarly, so other things are also, this sound is going to play, and all these things. So these things continuously we can do without any waiting. Without waiting, all these tasks can be completed and run parallelly. So this is all about the responsiveness. So for instance, you can continue browsing the web while the file is downloading in the background. So if the browser has to use only one thread, I have to wait for browsing my web till the download is complete. So my time is getting wasted. So that is the main advantage of multi-threading. So that the the download can happen, or you can have many parallel downloads also. 2-3 files we can download, and we can also browse. So this kind of things can be done with the same browser if you are using the multi-threading. Next, as already said, the better resource utilization. So the threads share the same memory and resources, reducing overhead associated with creating new processes. So when I'm using the multi-threading, the memory that all these three threads, they are going to share the memory that is required. So this is going to be the process. The processor is also going to utilize more better, and the memory is also we are going to use in a optimal way. Now, the disadvantages of the multi-threading: the difficulty in writing, testing, and debugging the code. So multi-thread programmings are generally very complex to write, because we have to do so many things like synchronization and share the resource. All these things we have to manage ourselves. So while we are doing the main coding, and this the side things like synchronization and resource management, these things also will take some additional coding. In that way, the code becomes little complex. But on the other hand, we are getting the advantage of the smooth running and all, but the background work will become little difficult. So then there is chance of deadlocks and race conditions. So what do you mean by deadlock? So the deadlock means where two or more threads are waiting on each other indefinitely. Say suppose two tasks are coming parallelly, but you first, like that. They may be waiting for the the other thread to start. Other task to be performed on the same thread. So you can say that the other one is the race conditions, where the outcome of the program depends on the sequence of thread execution. Says I have three parallel different tasks they are running, and if one task is completed first, I will get one result, and if the second task completes first, I'm getting a different result. That kind of things sometimes it can happen. So that is about the race conditions. So there is a chance of the deadlocks, where say suppose you can see in the traffic condition. So the two people are coming into the one thread, and they are waiting for the other person to go. This kind of things also can happen. So there is a deadlock and race conditions. So all these things are these are having anything will have some disadvantages. So these are all minor disadvantages, and we have to overcome while writing an efficient code, so that we can get the advantages. We can take the advantages of all the multi-threading. So this is some brief introduction of the multi-threading, and in the next class we will see how to write coding for the multi-threading. With this, these are some references that I have taken from Timothy Bird, Introduction to Object-Oriented Programming, Edison Willey, Object Technology Series, and Matt Westfield, the Object-Oriented Thought Process, Edison Willey, Object Technology Series, and Gordy Booth, the Object-Oriented Analysis and Design with Applications. And today I don't use any code, so I did not go for the Geeks for Geeks. So all these are the references that I have taken. And with this, we'll conclude our session. Tomorrow, in the next class, we'll see some coding aspects of the multi-threading. With this, I'll close my session. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.